The principle of remyelination work the same for both relapse-remitting and primary progressive MSers?
Yeah, that's a really good question. I guess the simple answer is we don't know at the moment. What we do know is that oligodendrocytes are very adaptable cells. So oligodendrocytes are the cells that make myelin at birth and throughout life. And we think that they behave in a very similar way, irrespective of the brain area they're involved in or even species. So for example, one can transplant stem cells from human into mouse embryos that lack myelin, and those human oligodendrocyte precursor cells will actually undertake myelination of an entirely different species nervous system. So they're an adaptable cell type. However, there really are emerging clues that there may be differences between subtypes of oligodendrocytes, so we don't know. And that may be relevant to polarized disease states. So it could be that oligodendrocytes from someone who has very aggressive primary progressive disease will be inherently different from those with relapsing remitting disease. One could imagine these days with sort of patient-specific or person-specific stem cells being able to take stem cells from individuals with polarized disease states and look at their myelinating capacities in cell culture in the lab. There's essentially nothing, to my knowledge, done on this at the moment, so I guess the answer is I don't know. There are other factors, of course, that will be relevant to the difference between primary progression, or indeed any progression, and relapsing remitting, including the sort of level of inflammation and neurodegeneration at various stages of the disease.
So then my understanding is that in order to be able to give at least an intuitive answer to this, you need to associate that with some additional factors. Is that correct?
Yeah, no, that's absolutely right. That's right. I think, and that's sort of a theme I'd like to build to, that thinking about just remyelination in and of itself is important, but there's a lot going on in the nervous system anyway, and it's particularly during myelin repair. There's lots of inflammatory cells, there's lots of dynamic activity. It's possible that inflammation can directly affect neuronal health independently of its role in myelin, so that you could get sort of in perhaps a primary progressive stage, you could get neuronal injury directly from inflammatory attack. So we really do need to consider all of these cell types in the sort of holistic setting, so to speak.